Hello everyone. Thanks for waking up early and attending this talk on Saturday morning. Can you hear me? Can you hear me at the back? Yes? Okay, cool. So there's no sound system. This is only for recording, in case you're wondering. So my name is Guillaume Taka. I work at Collabora, and this talk is about KernelCI. So I had a talk last year already about KernelCI at FOSDEM. This is kind of an update on what things have happened in the past year, but also about the future, really. So what is the purpose of KernelCI, in case you're not familiar with the project, and also what it wants to achieve in the longer term? So it's kind of climbing a big, tall mountain, really. We are trying to reach the point where kernels are released without bugs, and have at least quality control, so we know which bugs are in the kernel, and extending test coverage. And also having reusable tools. So the idea is to test the upstream kernel, but anyone using the kernel in their own downstream environment should be able to reuse these tools. We now have an official mission statement as written here, so that's basically what I'm trying to explain here, but this is like the official word we have now. So people spent some time making this up, so I thought it deserved at least a slide here. So yeah, last year I said maybe it will become a Linux Foundation project, and this has happened. So in October, KernelCI has become a new project of the Linux Foundation with all the members listed here. So Collabora, BladeLibre, Red Hat, Google, Microsoft, Foundries.io, and Civil Infrastructure Platform, which is another Linux Foundation project. Now we're still in the early days of what does that actually mean for the project. So we have a mission statement. That's the first step. We have a budget and some stickers, but there's a lot of other things coming soon, hopefully. There's a website also, a part of the website explaining what that means for the project. So although it has become a Linux Foundation project, the aim is still to be really community-oriented. So of course there are things that are done by the members for the members, but it's really to facilitate things to happen for the kernel community at large. So it's still focused on upstream completely. I mean, the tool again can be reused for other things. So if Red Hat wants to test the Fedora kernel, they can do that, or maybe the project will help make it happen, as an example. But it's still about testing the mainline kernel, upstream kernel. And it's still about sending email reports to mailing lists, and engaging more with subsystem maintainers and developers in general, to basically help people add their own tests to KernelCI. Every subsystem has their different workflows, and some maintainers have created their own small CI, which works perfectly well for them, probably. But then they might be reinventing some wheel and also not have access to all the hardware that KernelCI provides. So anyway, that's the kind of consolidation that is the main objective we're trying to achieve. So one kind of philosophy behind KernelCI is what we call the open testing philosophy, because there is only one mainline kernel. So in the same way that people from many different origins, for many different reasons, contribute to the same code base, the Linux kernel. When kernel 5.4 is released, that's for 5.4 that's going to run on a supercomputer, on an Android phone, or on anything. It's the same kernel, the same code base, although it does a lot of different things. So the reason why there are so many different test systems is because of these different use cases. But we could also have a common way of at least sharing the results, because some tests are relevant to all of these cases. If we want to test for memory leaks in the kernel, you can do that wherever the kernel is running. So everybody is doing their own product tests, but the idea is to have a test system that allows people to contribute their tests and contribute their hardware in the same way that they contribute the code. So yeah, like I said, so there's a large number of contributors. So yeah, basically that's what I'll explain here. The image is trying to say that we should try to have the same surface between tests and the code. So it's a bit like test coverage if you want, but align the two things, like the whole idea of having open source development and having open source testing, open testing on top of it, basically. Now, how do you achieve that? So this is like an abstract pipeline explaining how KernelCI works. For all of these blocks, there is at least one implementation, but you could have different things for each of them, different instances. So let's start from the beginning. So you have a developer in the top left corner, so someone writing some code. So the code ends up as patches. KernelCI doesn't test patches directly at the moment, but it can be done. Other systems do it. Or Git branches, then of course it gets built. The purple arrows are like when files and results are pushed to, then you have build artifacts. And after that, when you have a build, you can run tests and then process the results to detect when there was a regression, or basically see what needs to be reported from the results. And then your results are stored and analyzed to be able to then provide a report to the people and the developers. And this is when the loop is closed. It's like it's a bit like in automation when the objective is to have a working kernel. Like if you try to automate an arm, for example, like a mechanical arm, you want to know in which position it's going to be. If it's completely open and you just move something and you don't really look at it, you can guess where it's going. But if you have some sensors that will actually know where it is and you know the angle of everything, then you can have closed loop automated system. And this is kind of what we're doing here, except that it's doing this around developers and not around machines. But it's a similar kind of thing.
Sorry, can you speak up?
Yeah, sorry, I'll speak louder, thanks. There's a link here. You can so these slides are available as PDF. There's a link on the page for this talk, and on this slide 7, there's also a link to a shared document that has a more detailed description of the pipeline design, modular pipeline. So this is like the theory. Now in practice, what does that? How does that work? So right now we have KernelCI.org. There is one database that's being used for a long time, but we have a new one using Google BigQuery, and the idea is to use that as a prototyping database, but with access to more testing systems. So all the tests currently, the test results currently available on KernelCI.org are also sent to this database. And now we have also Red Hat submitting test results to it, and we would like to see maybe other people. So typically member companies would be the first ones maybe to contribute to that. So we're kind of refining the database schema for like storing build results and test results. And the first outcome we would want to have is have a unified test email report. So based on all that collective data, we could then send an email, say for a stable branch release or something. Instead, I don't know if you've noticed on stable branch mailing lists, on stable mailing lists, you have a lot of test results coming from different test systems. So that's one of the targets of having a common upstream kernel test system is to have only one report that's gathering all the data. So having this database is the first step. So if you look on the previous slide, that's basically the store bit. So yeah, store is artifacts and database, but this is at least the database part. Yeah, and then we can build kernels in different places. So that's the block number 2 build. How do you build? Well, if you have different people providing different like cloud compute and different ways of doing it, if you're modular enough, then you can include them. So that makes the project easier to scale. And right now we're using Jenkins, but we've changed it in a way so that it can run anywhere. So you can run all the KernelCI steps in a terminal, and some people have tried also using it in GitLab already. So Kevin is not here. Kevin Hillman has done this as a GitLab CI way. So he's using the KernelCI command line tools in a kernel branch. So automatically when your new changes are being pushed to the branch, it uses GitLab CI to build and test things like in other GitLab CI projects. But this could be used in other test systems as well. And also abstracting the lab API. So test labs are where hardware is available to test kernels. So by default we use Lava, which is the linear project for automating tests. But it's not there are plenty of other things. So we've made an abstraction in the KernelCI core tools so that it can submit things to any lab. So right now it's only sending things to Lava, but we can send it to any other lab that has a web API and can accept a test definition. So these are things we're working on. So yeah, the development goals, a bit more specific. So the command line tools are like KCI build to do to reproduce a KernelCI build from scratch. KCI test are to generate test definitions. So these are the things we're trying to improve so they become more portable. Also, we want to make it easier, like I said a bit before, to make it easier for people to contribute tests. So if you're a maintainer or developer and you have a test, or maybe you work on a part of the kernel and you make some tests for it, it should be easy for you to enable this in KernelCI. And right now, this kind of a steep learning curve. If you want to do this at the moment, you need to know too much about the internals of KernelCI to be able to add a test to the list. But that's one of the things we try to like lower the bar basically. And we need some good interaction with that. So we need some collaboration from the people who make the test as well. So we started with like a key people to try to do that. So maybe next year I'll come back and say, or maybe if you follow the project, you'll see maybe things will become easier. But right now it is not very easy. It's still a good thing. You know, if you have a test you really want it to be in KernelCI, you can send it to the mailing list or on IRC, KernelCI on Freenode, or KernelCI@groups.io mailing list, or just on the subsystem mailing list. People know about KernelCI. Now, also, yeah, we're trying to improve the web dashboard. So I don't know if you've seen the current KernelCI dashboard. But here we're showing mostly builds and boot results. It's not really, there is a test tab, but it's not really good at showing test results because KernelCI was originally about building kernels, like a variety of different ARM dev configs, and then about boot testing, and it's still kind of stuck in that phase. So we're starting running tests, but the results are not shown properly on the web front end, on the web dashboard. So that's one thing we're fixing actually right now to unlock a lot of things. There's many tests that were kind of held back because maybe we could run them and then email reports have some limitations, and if the web dashboard doesn't show all the results, then the tests kind of get hidden, and that's a waste of resource. But yeah, we still also need to improve the email reports. That's also a two-way process because it's hard to design something from the beginning. It's more like, you know, sending email reports and seeing how people react to it and whether they, you know, what is useful, what is not useful. And different subsystems or different mailing lists need different types of reports actually. So the key message, I guess, here is we need feedback. And if the email you get is not perfect, often people say, if you send another one like that, I'll just, you know, put a filter to put all your KernelCI emails in spam or in junk, something like that. Well, that's maybe, yeah, if it keeps getting bad all the time. But normally we try to like improve things as we go. So that's the key message is, you know, we can't get to a perfect thing from day one, basically. And also a slightly more longer term project goal is to improve test bisection. So we have bisection for boot tests, for you know, just plain boots at the moment. So like booting to a login, if you can log in, that's a boot. And that's very easy to bisect because it's only one pass-fail result per test, per run. But as we're running more test suites that have a lot of tests, then it becomes harder to bisect things when you have different test cases passing or failing at different rates. So that we have, I'll come back to this in another slide, but we have some ideas on how to do this as well. So reusable tools, yeah, so we have KCI build, KCI test, KCI rootfs, and there's, to create root file systems. There's a wiki page that might be written in a not too distant future, but right now there's a wiki page, kind of work in progress, that gives you at least a starting point if you want to see what these tools do. We also have the interface to the BigQuery database, so there's a command line tool for submitting KernelCI results to the common KernelCI. So if you have a test system and you're testing the upstream kernel, you want to submit results, you can get in touch and use that tool, and we can give you a token and then you submit your results. Then also Docker containers. I haven't worked on it myself recently, so I'm not an expert in the state of all of these, but I know that there's some good progress that has been done to have containers with a Lava instance with Jenkins configured for KernelCI, and the backend that's the backend currently used on KernelCI.org with MongoDB, and the front end which you see on KernelCI.org. So there are containers to make it easy for someone to recreate the whole system in their own environment. And again, if you try to find some issues, it's all on GitHub, on the KernelCI project on GitHub. But we need more people to use it, basically, to get some feedback on it. So yeah, about advanced bisections. So there's this tool I worked on called Scalpel, which is inspired by EasyBench, which was written by Martin Perez at Intel. So we've been talking because he made this tool for graphics testing. It's actually not really used in production EasyBench at the moment, but it had a much more advanced bisection feature than the normal Git bisect command you have, because this can deal with several test cases at the same time. So when you run one test, you can provide the results for many test cases. It can also request tests to be run several times if they are not stable. So the Scalpel project is basically extracting this and boiling it down to a more portable thing that can be used. And if you look at the project on this GitLab project, you can find there's a demo that will run, like create a Git history with like dummy pass-fail things, and it will find a problem in it. And it's kind of ready to be used in KernelCI, but it will come a bit later, I think. But I hope that will really help for some things. So people say maybe we should be testing patches as people send them, because when you have one patch on the mailing list, you can test it on its own and you know if it's good or bad before it gets merged. And yes, that's ideal, but it means there's a lot of patches. So adding, supporting all of it, and building, if you want to build all the kernel configs we build, or even a subset of that, say if you want to build 10 kernels for each patch that is sent and test it with 200 different platforms, and that doesn't scale very well, I think. So maybe in some cases, if we do it wisely, we can only test a subset based on which subsystem the patch was sent to, but that can take a lot of tweaking. So the idea of the whole advantage of having bisection is when you test Linux Next, for example, where all the new patches that have been applied are merged together, and if something breaks at this point, then you only need maybe 10 iterations to bisect from yesterday's next to today's next. So you build 10 kernels basically to find when you know that there is actually a problem. So you can be very efficient. So that's why bisection is such an important thing for KernelCI. Okay, so tests, wish lists. So these are the things that have been identified so far, but again, maybe some people would think that network keeps failing all the time. Other things maybe are also important to test. But these are kind of obvious things that are directly to the ones at the top are the ones that kind of come with the kernel. And we're not really doing them too well right now, but I think that's like an obvious list of things we should be doing. Linux test project, I know that LTP that was mentioned a bit earlier, that's at least some parts of it, because some parts may not be completely relevant to the kernel, maybe more like user space oriented, but there are definitely some things in there that you would expect to be run on a kernel test system. And then some are more subsystem centric, like for media subsystem you have Visual2 compliance and other things, and IGT and XFS tests. There's a lot of them basically, and this is where more integration with, more communication with the subsystem maintainers and developers needs to happen. And that's basically like a summary of where we're trying to be, where we're trying to go. There's a lot more that can be said. It's a very big project, and it's kind of old because it has been around for 5 years, but it's new at the same time because now we have a budget and we have some ideas. We have a lot of limitations have been removed since we've joined the Linux Foundation. So I'm hoping it's like a rebirth for the project. We need also some engagement from the people. We need people to realize that now, this has been selected by the Linux kernel community basically as the main project for testing upstream, and you can reuse it for your own products as well. So, does anybody have any questions? Yeah.
Could you please just mention the technologies that are used for the tests, like what kind of languages are the tests written at, what kind of technologies are used in the stack?
Okay, so the question is about the technologies used for testing in general. So there are many different things. So the tests that come with the kernel are normally written in C, like a self-test, or you have some shell scripts as well. And well, the static analysis coccinelle is a separate language. And KUnit is also written in, Ksan and these are like built-in things, so the kernel configs you enable basically. And KUnit is a bit the same, it's part of the kernel, so it's all written in C. Now you can have, there are also some test suites, basically the quick answer is a lot of it is written in C because it talks to the kernel, so it does a lot of system calls and it makes sense to have a low level.
There's no high-level language that the tests are described in a declarative form or anything?
Sorry, can you repeat?
In other user space projects, we're testing using a high-level language that,
okay.
declares the test, and then that is translated into the native language of the project.
Yeah.
But there is no such language for the kernel yet, is there?
So the question is whether there's a high-level language to define the tests and then run them. So yeah, for example, the tests run in Lava, there's a YAML definition that explains what needs to be run, and then you will have some commands there that might be binaries or maybe shell scripts or maybe Python. So it depends. Each test suite has a different way of being run. Yeah. I think you were second. Yeah.
So for a single test run, what's the average runtime, and what would be considered like a reasonable runtime for a single run test or test run?
Okay, so the question is for one test run, what is the usual runtime and what's the expected time for that, basically?
What would be reasonable?
What would be reasonable?
Yeah, like not a day maybe, but...
Okay, so of course so the question can be answered in different ways. So if you want to test everything, then you can add, time, how long it takes. Of course, some things run in parallel, so it's going to be like, until you get the whole results, it's going to be what takes the longest. That can also be done by splitting test suites into smaller things to run more in parallel. So there isn't a simple answer to that, but what is desirable basically from a time duration? I think it depends on where in the process you are, where in the kernel workflow you are. So if you're sending a patch, for example, you want the result to be quick enough. If it's Linux Next, because there's a version every day, you expect to have the results maybe within like 6 hours. That wouldn't be too bad. Or maybe 12 hours even if it's running a lot of things. If it takes more than that, then you have more kernel versions to test than the times it takes to actually run the tests. If it's for stable release, maybe you can run more tests that will take 2 days and it will be valuable. So it depends on which version of the kernel at which stage you are in the development.
So the context of the question is more like if you would like to use the Docker image and put it on, say, Travis CI and have like free version, the limit there is like 50 minutes for a single Docker run. So basically you would have to design things to work within that limitation unless you want to go for the paid version, let's say.
Okay, so the question was about integrating it in Travis CI as an example.
Comment more than
Yeah.
a question.
So,
It's related to the question.
Yeah.
The idea is that if you want to run it in Travis CI
Yeah.
as a Docker,
Yeah.
then the limit is 50 minutes
Okay.
for the free version. So what you can do is, for a single Docker,
Yeah.
so then you have to split it up in, let's say, if it's 500 minutes, then it's 10 Docker parallel, divided into 10 Dockers running in parallel, let's say.
Okay. Yeah. So it was a comment about if you wanted to integrate it in Travis CI with a limit to 50 minutes, basically you need to accommodate things around. You can also like build only one kernel version if you know the diff config, the architecture you care about. and then yeah.
Does it even make sense to run things in Docker because you are not running the kernel you built, right?
I guess, so the question is about, does it make sense to run Docker? You could use Docker to build a kernel and run things that will,
The kernel test in Docker is kind of moot point, right?
well, you can use Docker to build a kernel at least.
Yeah.
So you have an environment to build it. Anyway, yes. Yes.
So how are tests being triggered? Do you need to submit them to KernelCI actively, or do you scrape pull requests off the mailing list? Because I guess that's the eventual goal.
So right now, there's a list of Git branches that are monitored every hour. So the question is, how are KernelCI tests triggered? And the answer is, right now, there's a list of Git branches that are being monitored. You can see them on, on the website here. You have trees and branches. So all these are monitored every hour, and the system knows the last version that was tested. And if there's a new version, then it triggers the whole thing and it builds a bunch of tests.
So pull requests to master, it's the maintainer's trees. So to speak.
It's even if one more commit was pushed to the branch, that's a different revision at the head of the branch, and that's enough. Now, like I said, also we've proved that it can work in a GitLab CI environment, where it's when a typical GitLab CI workflow, and that can trigger things as well. So you can reuse the same tools in a different setting if you want to. I think maybe you were next. Yeah, and then okay.
5 minutes?
Okay, so 2 more questions. Yeah. Yeah.
Okay, so if you want to move to testing like patches on the mailing list, how are we going to define which test suits to run? Because we obviously don't want to run them all. But what if there is a patch to like memory management break in file system or KVM?
So the question is if
Yeah, but how, right? You need to look at the patch, right? It's been sent to test one mailing list, right?
yeah. So the question is, if we start testing patches, how do we determine which tests to run, basically? So first, which mailing list it was sent to. That could be a clue. And then, of course, you can do some stats on the files that it's touching. And you can also, right now we have some.
There are already tools that are analyzing the patches and looking at the files that are changing,
Yeah.
and trying to figure stuff out. I guess that's what the Red Hat kernel testing stuff does. So people are working on solutions.
But yeah, so we have a YAML-based configuration at the moment for each Git branch which test to run. We could have something like that for patches. So depending on which mailing list it was sent, and maybe some people will care more about some things, like some maintainers will say every time I push something, or well, maybe maintainers don't send that many patches, but we could have any kind of arbitrary rules. I think there was a question here.
Yeah, I was just wondering if it's also across like arbitrary reports that you're monitoring.
If we're monitoring across.
Like arbitrary reports, like it could be personal instance, it could be a request server in GitHub, it could be.
So we're monitoring a lot of different branches. So the question is, are we monitoring any random branches? So we're monitoring the main ones, of course, like mainline and next and stable, and we're doing as much testing as we can on them. Then we're monitoring subsystem ones, and we do a lot of testing, but maybe a bit less. And then the further away you are from the mainline master branch, the less testing you get, basically. So it scales in that way. So you could have an individual branch, from like a maintainer or an individual developer. Maybe if you have like only 1 or 2 kernel builds and you do only a few tests on that, then it will, for one Linux Next, if you do 200 builds, that's like 200 people doing one build, basically. So that's the way it kind of scales. If the community think it's useful to have a branch, like when someone wants to have a branch added, they send a request, basically. If people think it's a good idea, and if you have enough build and test resources, then it can be added. Well, the main rule is, I guess, that it needs to be upstream oriented. So if it's a downstream branch for your own product, that's not something that would be on KernelCI.org normally.
Last question.
Okay.
So you said you were building a generalized lab API to integrate with the KernelCI, right? So I was wondering, what kind of functionality does your lab need to support in order to integrate correctly with this variable CI?
Okay. So the question was about a generic way to talk to labs. So right now, there's a command line tool called KCI test. If I show you, so basically it's about the bit when we have a build and you go to the run box. Basically, that's when you start to test. So Right now we're using, so this command line tool KCI test is in Python, and there's like an abstract class with some methods, like there's one like to generate a test definition, another one to submit a test definition, and we could add other things like receive the results. So right now the results are sent directly to the backend. In some cases we could like have the test lab send the result back to a place where KCI test would be used as well to receive the results and process it and store it in a database. So these are kind of the main primitive functions. And to really have it work in practice, we need to test it with more labs. Right now it's kind of only working with Lava, so it's still not very mature, but that's basically where it's going. So I think we've run out of time. Yeah, thank you very much for watching.